Okay, so in the lectures previously, I tried to explain to you the logic behind transformation. But I find that students have really hard time trying to follow that logic. Okay, so horizontal is reverse, vertical is, you do it the way you do it. Students often get lost. So let's summarize what has happened and turn that into a process. Okay, so what we do is, let's do an example here. Y equals, let's say you have a root of x plus 2, and then maybe you have a plus 3 outside. The first thing you have to do is, what is the base function of this? And I hope you can see that the base function, okay, you can recognize the base function because it's everything that's not multiplication or plus or minus or division. So you see plus plus, the root function is your parent or base function. And then you have to ask yourself, what if you were to replace x with an input? Let's say if you put like 5 in there. What do we do to that input before the square root? So here's square root. What do we do before? Let's put that on the right, left. Let's put what we're doing on after the square root on the right. Clearly, we're adding 2. And then we're square rooting it, and then we're adding 3. Okay? So for the horizontal, okay, whatever happens before the square is your horizontal transformation. And to get your proper transformation, we have to undo this operation. So plus 2, the opposite of plus 2 or inverse of plus 2 is subtraction of 2. So x becomes x minus 2. For the vertical, you copy and paste the operation. So this is the transformation mapping from this to this. Okay, so it's a horizontal shift of 2 units to the left, vertical shift 3 units up. Okay, and we know that 0, 0 in the original root function, right? 0, 0, we have 1, 1, and we have 4, 2. Okay, 4, 2. Once you have the transformation mapping, you can just plug the x and y, these x, y values in here to get your new points on your new transform graph. Okay, you get that, right? Just remember, this was the starting point. So this will also be the starting point. So the relative position does not change. So negative 2, right, and 3. Negative 1 and 4. And 1, 2, and 5. Okay, that's a starting point, and we have to head towards the other point. So that's your graph. Okay, let's do one more that's a little bit more complicated. So this time, I'm going to put 2x plus 4 times by negative 2 plus 3. Okay, that's our parent function. What happens before the root function? 2x. First of all, we're timesing it by 2. Second of all, we're adding it by 4, and then we're square rooting it, and then we're timesing it by negative 2, and then we're adding 3. So this right here will transform the x, and we have to do it in reverse order and inverse operations. We first have to get rid of this, which is x minus 4. And then to the result, you have to do the opposite of this, which is divide by 2. To the y, you don't do it in reverse. You just do it from the same order. Okay, this one is reverse, this one is not. Okay, now you plug in 0, 0, and we get negative 2, 3. Plug in 1, 1, negative 3 over 2, and 1. And plug in 4, 2. You get 0 and negative 1. Okay. Okay. Negative 1, negative 2, 1, 2, 3. And negative 3 over 2, 1. And 0, negative 1. So we start from here and we go down. Okay. Another big common mistake is that when students see +4 here, they think automatically it shifts left 4 units. Look what happened to the graph. It only shifted 2 units to the left. So I'll address that because it happens so often in the next video.